In this first part, we will light a white LED through a series circuit. For that reason, we will need a breadboard, a power supply module, and a battery with a snap-on connector. The battery is of 9 volts. Also, we need a 330 ohm resistor, a white LED, and a force resistor. So we start with the process. Now we need to prove the circuit. So for that reason we need to click on switch and the LED should need to light up. And it's correct the circuit. And this happened because the energy is flowing correctly. As we can see in this round, the current is centered as a positive with 5 volts and it's followed until 330 ohm resistor. Then it enters as with a force resistor and is out with a white LED. And then it follows and so on. And we can observe that if we cover the force resistor like this, the power light is decreases because we're interrupting the flow of the energy and that enters. So this is how the series circuit happens. On this second part, we will make a parallel circuit with the objective to turn on a LED light and prove the function of the photosensor. For this part, we need 330 ohm resistor, a photosensor, a light LED, and 2 wires. So we start. So now we need to prove if the circuit works. So let's do it. So it works, and this happens because if the photosensor do not receive light, it has a high resistance, and the current prefers to continue to this side. And for that reason, the LED is turned on. It's weird because in this moment we have light, but the photosensor take this like a darkness. But if we approach the light, so like this, so the LED is turned off because the photosensor has a less resistance and the current prefers to continue to this side. And for example, these wires are bridge where the current flows. So as we can see in this drawing, the current starts here with a volt, so with a voltage, and continued until resistor, and then the current stops here in the node. So, and the node detects which side has less resistance, and choose the side with less resistance and produce the output. And as we mentioned before, if this one has the light and less resistance, the output is going to be turned off the LED because the node is going to continue to this side and this side. So the LED is going to turn off, and this is how the function of the circuit. Then in the third part, we will make to turn on the LED light with the darkness. Now we need a transistor, a 330 ohm resistor, a 100 kilo ohms resistor, a light LED, a photosensor, and 2 wires. So let's start the process. So now we need to prove if the circuit works. And it works, and this happened because the transistor changed the function of the photosensor. In other words, the transistor reverses the function of the photosensor. For that reason, when the photosensor is dark, like this, it gets less resistant and the output is going to be the light turn on. And in this drawing, we see the representation of the circuit. This is part 4. In this part, we need a microcontroller, 1, 2, 3, and 4 wires, 2 resistor, one of 330 ohms and the other one 5 kilo ohms, 1 photosensor, and a light LED. In this part, we are programming the circuit with the objective to turn on the LED light. Also, when you pass your finger in the photosensor, over the photosensor, the light turns off. In this part, we have 2 circuits. The multiply divider and the link. This wire that is for 8 provide to this circuit, and the another wires is to provide for this circuits of the multiply divider. So in the computer we have the code, and this is the way the circuit function. This is the code that I use it for the 4 part that is composed for 2 circuits. And as we can see, we have all this.